This lesson is on Chapter 2, Section 5, Transformations of Functions. So if everybody would please turn to an empty page in their notebook and have their textbook open to page 205, we will get started. All right, so with transformations, we're going to be looking at moving around and shifting these graphs that we've been looking at, these function graphs. Now we need to start becoming very familiar with the parent functions and what they look like. So for example, we should all know what f of x equals x squared looks like. It's a parabola that starts at the origin and it curves up. Okay, things like that that we studied in, I believe it was section 4, we need to become very good at looking at a picture and knowing, okay, that's a quadratic function, or that's a cubed function, or that's a square root function, and so on. So now today, we're going to be moving those and shifting them. So a couple of the ways that we're going to be shifting those functions is up and down. Now a vertical shift up will happen when you add a number to the original function. Okay? A vertical shift down then is going to be when we subtract a constant or a number from the original function. We can also shift things horizontally. So if there's going to be a horizontal shift, we're going to subtract an amount from the actual x in the function in order to shift the graph to the right. And if we want to shift the graph to the left, we are going to add a value to the actual x of the function. Okay, so we're not adding or subtracting numbers from the whole function. We are just adding or subtracting numbers to the x value of the function. So let's take a look at this one. All right, so use the graph of f of x equals x cubed to sketch the graph of each function. Now, if you turn back real quick to page 202, okay, you can quickly find what f of x cubed should look like, or f of x equals x cubed should look like. In the parent function section in the middle there, it was graph f. All right, so it's kind of that curvy one that's symmetric about the origin. Now, what we're going to be doing to it is adding 3 to it. So what does that shift end up doing? Well, I want you to think about a couple of points here. For example, if we did h of 0 right now, we would have 0 cubed plus 3, or 3. So instead of this graph starting or going through the origin, it's actually going to go through 0, 3. Okay, now from there, we know that it's going to take on that same curve shape that the parent function had, but maybe you want to still put in a couple of other values just to find some points to graph. So let's try h of 1. We're going to get 1 cubed plus 3, which is 4. So 1, 4 is another point. Maybe we want to do h of negative 1, which is going to be negative 1 cubed plus 3, which is negative 1 plus 3, or 2. Go maybe another one out both directions, h of 2 and maybe h of negative 2, just to get the steepness of how the curve is going to take off. So 2 to the third power plus 3 is 11, and negative 2 cubed plus 3 is going to be negative 8 plus 3, or negative 5. So 211 is a point, and negative 2, negative 5 is a point. Now you can kind of see how that curve is going to take shape. Do you see how it ends up still looking like a parent function? It just shifted up 3, and we could tell that from that initial equation of x cubed plus 3. All right, so let's take a look at this one. We have a couple of things going on here. I still see a cubed piece in this function, so I know I'm still working with that same parent function, but there's a couple of things going on. I see a plus 2 at the end. We know a constant tacked onto the end of a function amount is a vertical shift up. The x minus 3, so subtracting a number from x itself, remember, was a right shift of 3. Okay, so this is going to start not where the original one did, but up to and right 3 from where it did. And if you were to plug in 3, okay, if we were to do g of 3, you would end up finding that you're going to get 2. So 3, 2 was a point to graph. And again, you can do a couple more if you want. Let's maybe try g of 2 and g of 4. Okay, so g of 2 is going to be 2 minus 3 cubed plus 2, which is negative 1 cubed, which is negative 1, plus 2 is 1. So 2, 1 is a point. And if we were to put in 4, we'd have 4 minus 3 cubed plus 2. That's 1 cubed plus 2, or 3. So when 4 went in, we got 3. And you can kind of see how the curve is going to start forming. Just like that. Another way to shift or transform a function is to reflect it. You guys talked about reflections in earlier years. They are when you flip the function over a line of reflection. So if we end up with a function that is the negative of a parent function, okay, it's going to be the opposite of it. It's going to be the reflection or the flip of it. Okay, if we reflect it over the y-axis, okay, so that first one was a reflection over the x-axis. Reflection over the y-axis is if your new function is the negative x in the parent function. Okay, so if you have f of negative x, then you are reflecting over your y-axis. Okay, so reflecting over the x, the entire function is the negative of its parent. In the reflection over the y, then it's the x part of the function that is negative. Let's take a look at a checkpoint problem. At the bottom of page 208, we've got a checkpoint down there with a square root 1. Prior to this one, I think it would be a good idea for you guys to look through example 3 that's in the textbook too. Okay, so this one's a little bit like that. It'll give you another idea. You've got the one in the book, and now we'll have this one as well. So taking a look at this one, we have g of x is equal to negative square root x minus 1. Well, we have a parent square root function. Okay, again, if you need to, go back to page 202 and just get your head familiar again with what that parent function looks like. That one is D in the middle of that page. So it started at the origin and it kind of curved off just into the first quadrant. Okay, so if we're going to take negative of that, okay, that means we're going to be reflecting this one over the x-axis. It's a negative of the function itself, not just a negative of x. And then we also have that minus 1. So that's also going to be giving us a shift. Okay, so when x minus 1 is inside there, that's going to give us a right shift of 1 as well. So we've got two things going on here. We have a reflection going on here, that's this part. And we also have a right shift of 1 indicated by this part. Okay, so knowing that our parent function started at 0, 0, and we have a right shift of 1, we can tell that this one's going to start at 1, 0. Now, the parent function, I'll do that one in black, took off like this. Well, if we're going to reflect that over the x-axis, which this negative sign tells us, what would the reflection of that curve look like? It would look like what I graphed in red. Okay, so you certainly can always pick values for x and plug it in and come up with some actual things to graph. but we know that it's going to be a reflection because of our rule on the previous slide, so you can just go ahead and draw it in as well. So how about if we were looking at this one? H of x is equal to square root of negative x minus 1. Okay, so we still have a square root function here, so we know what the parent would look like. We'll draw that in again. So there's your parent function. In this one, we have negative of the value, okay? So that means we're going to reflect it over the y-axis. And we also still have that negative 1 in there. So we still have a shift going on. So on this one, let's do a couple of values on this one. This one's a little bit harder to get your head around. Now, we definitely cannot end up with negatives underneath the square root sign. So if I put in a negative 1, I'm going to get square root of a negative of negative 1 minus 1, or 0. So negative 1, 0 is my first part. Okay? Now, with the reflection piece now, reflection over the y-axis, you can probably fill in the rest of this curve, but let's give us a couple of more points. Let's try h of negative 2. Now we got the negative of negative 2 minus 1, which is 2 minus 1, or square root of 1 being 1. So when I put negative 2 in, I got a positive 1. Now can you see where that curve's going to go? So look at it. Do we have the negative 1 shift? And did we reflect over the y-axis? Yes. Okay, a non-rigid transformation. So here's another kind of transformation that this section talks about. We have essentially 4 non-rigid transformations. We're going to stretch and shrink. Okay, with our rigid transformations, the shape of the thing didn't change. Okay, its position and where it started did, but it was still essentially the same exact shape of the parent function. Now, by stretching and shrinking, I think you can tell what's going to happen to the look of those graphs. So a vertical stretch happens if you multiply the parent function by something bigger than 1. Okay? If you're going to shrink it vertically, then you're going to multiply it by a fraction or a decimal between 0 and 1. Horizontal shrink is if you multiply the x part of the function by a constant bigger than 1. And a horizontal stretch is if you multiply the x of the function by a fraction or decimal between 0 and 1. Okay, so the horizontal and vertical shrinking and stretching kind of has the same concept behind them. You're going to have to pay attention and keep straight what does what to what. Okay, so in this one again, to review, vertical stretch, multiply the whole function by something bigger than 1. Vertically shrinking, you multiply the whole function by a fraction. For the horizontal shrink, multiply just the x part by a constant bigger than 1, or a number value bigger than 1. It doesn't have to be a whole number. Horizontal stretching, multiply just the x part of the function by a proper fraction or decimal. So let's take a look at one of these. All right, so I've got an x squared thing going on in this function. So I know I'm thinking about the parent function f of x equals x squared. Again, if you don't remember what an x squared parent function looks like, go back to that page 202. That one happens to be letter E in that parent function summary. So we know it's going to look like a parabola. All right, so starting with this one, we're going to get, okay, we're multiplying the whole function by a constant. So if you think back, that was vertical stretch. Multiply the function by a constant bigger than 1. So we're going to be stretching this thing. So a couple of values there. If you were to put in g of 0, we're still going to get 0. So the vertex of this parabola is still going to stay at the origin. But what happens when I, for example, put in g of 1 now? I'm going to have 4 times 1 squared. So rather than just having 1 squared if it was the parent function, I'm going to multiply it by 4, which gives me the point 1, 4 to graph. And it would also be the same because it is a quadratic with that x squared term. I'm going to get the same thing if I put in a negative 1. So do you see how this is going to stretch? It's going to go up narrower and faster than the parent function did. It's going to be stretched. So let's take a look at this one. Now take a look. I've got the parent function yet, x squared, but I'm going to multiply it by 1/4. Let's take a look and see what that does to this. So again, at 0, you're still going to have 0. But what happens if we put in, I'm going to actually pick a purposeful number here. I want to pick a 2. I'll have, whoops, skip that, 1/4 times 2 squared, which is 1/4 times 4, or 1. 2, 1. And it's also going to work for negative 2, right? Negative 2, 1 are points. Look how much fatter that curve is going to open up. Okay, so multiplying that parent function by 1/4 really moved it or widened it out like that. Strangely enough, they call that a shrink. Okay, maybe you want to think of that as shrinking in height, rather than thinking that that was a stretch. Okay, at the bottom of page 209, look there now. Okay, I've got these two graphs on here. We're going to still look at a horizontal shrink and stretch. So if I'm looking at g of x is equal to f of 2x, okay, g of x equals f of x, that's just your basic linear function, right? Okay, so if we're looking at 2 times x, let's see what that does to our values. Okay, so if I were to pick 0 again, my f of x equation is x squared plus 3 for this one. Okay, so if I've got f of 2x, that means I want to put 2x in for every x in the f of x. So instead of having x squared, you're going to have 2x squared plus 3. Okay, so 4x squared plus 3. Now put in your 0. We'd have 0 plus 3, or 3. Okay, now let's do a couple more points yet. How about g of 1? So now we're going to have two times 1 squared plus 3. So 4 plus 3, which is 7. So 1, 7 is a point. If we had g of negative 1, let's try that. So putting in our negative 1, we get 1 squared plus 3, which is 4. So negative 1, 4. Whoop. Negative 1 times 2 is negative 2. Sorry, back it up. Got to do my inside the parenthesis first. So negative 2 squared is still 4 plus 3. That looks better. Because we know we still want to end up with a parabola here. So you can get your tendency now, and you can figure out that the rest of your curve is going to go like this. One more to try. Okay, so let's first of all figure out what our function's going to be. H of x is equal to f of 1/2 x. Okay, so bringing back that thing from our previous one, these kind of went together. So f of x, I'll just rewrite it here, remember was x squared plus 3. Okay, this a and b were kind of in the same set of checkpoint problems. So if I want 1/2 x in for every x, let's take a look at what that's going to look like. Oops. Instead of an x squared, we're going to have a 1/2 x squared plugged in. So now let's try h of 1, or h of 0 we'll do first. So that's going to give us 3. So that plus 3 on our first function, x squared plus 3, it shows there. Okay, so we had a vertical shift going on of 3. But now let's come up with a couple more values. Let's put in, I'm going to put in 2's this time, because I know I'm going to be multiplying 1/2 by my x, and that just works nicer. So I get 1 squared plus 3, which is 4. So when I put in 2, I got 4. Let's go with negative 2 then. 1/2 times negative 2 squared plus 3. I'm going to get negative 1 squared, which is still 1. And I get another 4. And you can finish off your curve. Okay, one more to do. In your homework, I'm going to be giving you some problems assigned again. And this one is going to be kind of close to one of them that I'm asking you to do. And because it had so many parts in the directions, I wanted you to have one that you guys can look at. So this one's number 21 from the homework page, page 211. And in the directions, it says, G is related to one of the parent functions described in section 2.4. Identify the parent function f. B, describe the sequence of transformations from f to g. So what are you going to do to your function? C, sketch it. And then D, use function notation to write g in terms of f. All right, so what does all of that mean? Well, first thing to do is we need to figure out the parent function. So if we're looking at g of x being 12 minus x squared, you see the x squared in there. Okay, so the parent function for this one has to be our x squared one. So our parent function is the f of x equals x squared parent function. Okay, now take a look at the things that you're doing to it. First of all, notice that you do have a 12. It is a positive 12 tacked on to the whole function. So that part right there indicates that we're going to have a vertical shift of 12 up. And what does the negative in front of the parent function end up meaning? Okay, that means we're going to have that reflection. So the negative in front of x squared tells us that we're going to have a reflection on the x-axis. Okay, so all of those things are on the previous slides for this video. So flick back if you have to and review those things. But I've got a negative in front of my parent function x squared, and I also have a plus 12 sitting there added on. So these two shifts are happening to my graph. So what does that end up looking like? Well, if I'm going to have a vertical 12 shift, my graph paper's not great here. It's going to start here. Now, when this parent function would have been graphed, okay, we all know what x squared looks like. roughly like that, right? Okay, if we're going to flip that or reflect it over the x-axis, it's going to go down now. And some of you guys maybe remember that when you were graphing parabolas that had a negative coefficient on the x squared, they went down. So this one is not going to loop up like the parent function did. It's going to reflect down. Okay, so that's part C, is the sketch. Part D had us writing g in terms of the function f. Okay, so the parent function, remember, was the x squared part. All right, so all you do, this is what's meant by that, your g of x function is going to be 12 and then minus the f of x part. Okay, the function is f of x, that's the x squared part, so you just substitute f of x in for that piece. Okay, well, so hopefully that helps you out with one of your problems. Here are the ones that I want turned in on Monday. I only gave you 4 this time. The assignment as a whole starts on page 210. I would like 12, 14, 16, and 22 done for Monday. All right, so remember there are odd ones right next to these that are going to be very similar to them. Do them first so that you understand completely how to do it if you're not quite sure still. And I want those 4 on a separate sheet of paper turned into me for Monday. Okay? All right, that'll do it for me.